Alright, I worked on my schematic some more to make it make more sense. And it's essentially a transmission line in the tradition of Eric Dollard. And it's a transmission line in longitudinal magnetodielectric mode and in transverse mode. It's a combination of the two, actually. I can't say what the Earth represents, but this top line up here with this capacitor would be longitudinal, but then we've got this connector here, this electric keeper, that's transverse. So, and then this, I guess, is negotiable, somewhere in between these two extremes. But each point is anchored to the Earth. It's just a different type of or a different situation that's being anchored. These two are stable because the magnetic flux does not vary in and of itself. Lenz's law does not self-induce, while in a piece of wire it does, or in this piece of wire wrapped around the iron keeper, the magnetic keeper, will indirectly affect the flux. So these two positions are stable. They're like pillars of a temple. But this is where the action is happening because it drains the system. So this is an area of instability due to the fact that you can get a reaction from this loop of wire. The Lenz effect is action and reaction, but which is where we can harvest our power. But magnetic flux, you can't harvest it directly, at least not electrically. I mean, at least not magnetically directly, except for its action upon other magnets. And then you can harvest kinetic motion. But the Lenz effect only applies to the electric field, not to the magnetic field alone, strictly speaking. Or I should say, the Lenz effect is the relationship between the electric field and the magnetic field. But in a magnetic keeper, you can have magnetism all by itself, which is why it can go on indefinitely. You just don't get to have this go on indefinitely and harvest it at the same time. So we harvest it not from the magnetic, but from the electric keeper, the electric loop. And the load I've placed down below here. Here's the captor loop. Here's the same diode position just like here, because this whole system I think is designed to be DC and exclude AC. And then we skip past this bottom end of the electric keeper but connect with it at the top end and then go up to a middle plate. So this is a 3-plate capacitor, which means the sign on either side is going to be the same, which is a little weird to put it mildly. But that implies that the potential here and the potential here are going to be equal in polarity, while this is going to be the opposite. So if this is positive and this is positive, then this middle plate is going to be negative. Which is a little weird, to put it mildly. Oh, well, that affords the opportunity, because of this direct connection to the loop, the electric keeper loop. This loop is negative, while this loop around the center post here is positive, and this one is positive, with reference to the 3, if we're referencing among the 3. So actually what we have is an AC alternation as we work our way down the line. So in that sense it's AC. You see, normally I think of a transmission line of having one up here and then I'm using the ground down here, and then it would alternate between them, but that's not the case here. It's the opposite. I'm alternating every other pole is positive, negative. That's actually what's happening. It's a different orientation. I don't know, why I drew it this way. It just seemed more better. What do I know? Where's my focus? So the middle plate is connected directly to the top loop, and then we skip over to the load, and then a capture loop inductively coupled to the bottom of this electric keeper, and then through a diode opposed, and then to earth ground. While this one comes up and wraps, I'm drawing the wire behind the magnetic keeper here. It comes up and wraps around the center post, comes up with a direct connection that goes to this capacitor plate, and of course goes off to a similar situation off schematic there. So there's a direct connection here, and then up to a resistor, up to a neon bulb, and then up to an aerial plate, an elevated plate. Same thing over on this side. And so the wire goes off to an indefinite infinity there. I guess the only way to terminate would be to not have this extended wire, unless, no, you take this and loop it back to here. Same thing here. These two loops would loop back to here, and we'd have another one on the outside. So we'd have to have an even number, which means it would be balanced, negative, positive, negative, positive. So we'd have an even polarization, because we'd have to have it in pairs. We'd have to have an even number of poles. So that means we have another opportunity to power a load over here as well as over here. Now, if this is going to be a loop, a circular loop, a daisy chain loop, then I don't know how to expect, normally in a transmission line where you get the AC alternating like this, then the power should increase as you go down the line, but that's because it's in series. If I'm looping it around, I can see why I'm changing my orientation of AC polarization to this frame, to the vertical, because it doesn't build. It simply alternates. So negative, positive, and then back to negative again, or the inverse polarity, whatever it happens to be. It may swap back and forth, is what I mean to say. So it's not going to be a series build, unless it's a pulse build, unless the system builds up by flipping polarity among the different poles. I would consider this a pole piece right here, because it's based on this pole, a magnetic pole, while this one is an electric pole, especially since I have a capacitor up here. Well, no, I have a capacitor up here. Whatever. So it might build just in a different fashion, not in a serial fashion, but in a alternating fashion. I don't know. It's a different way to do it. It's just weird. It's just basically just weird. And then I got rid of the idea of this sleeve around here, because I don't know what to do with it. Quite frankly, just because they put it on a pole transformer doesn't mean I know what to do with it, because if I do a capacitor sleeve between the magnetic pole, the iron pole, and the wrapping, the coil winding, where do I connect, if it's a capacitive sleeve, where do I connect the leads of those capacitor layers? I've already got this wire grounded. I can't bring it down to here. Unless I bring it over to here and make this a center plate, just like it is up there, put another capacitor down here. But now I'm not using the earth as a substitute for a capacitor. I'm using it simply as a ground. Which is kind of weird, because then I'd have a capacitor here in addition to here, but instead of having it here, because I have it up here, a one-sided capacitor. Oh, could I put a one-sided capacitor here? I could. Would I link it up with that? Ooh. Oh, that's weird looking. Let's step back a bit here. Whoops, too far. Okay, a little closer. So unlike this, this is an elevated capacitor plate. Maybe because we got a load. So here we're trying to elevate everything, potentials. Here we're trying to depress potentials due to the fact that we got a load engaged. But that's a one-sided plate. Well, yeah, the Earth is one-sided. Well, the load is considered the equivalent to the top load there. We just have it down below over here. Because we need it directly connected to this electric loop, because it's shorting out so that the circulation in the loop is carrying down through the wire and then down to the Earth, or else the other way actually. And this might have to be flipped. I don't know which direction it's going to go. And maybe it alternates. Maybe it goes this way on this pole, but over here it goes the opposite way. That could very well be. Yeah, I should draw out 4. I should redo this to have 4 to show that this loop alternates its direction. But if I put a sleeve here, I don't know what to do with it. That's my problem. What do I do with that sleeve? Because in a sense, this center plate is your top load. So I bet maybe I have this wrong. Maybe this top wire is the top load, because it'll act like an aerial, which means I have to move this down to here. Weird. That could be true. That could very well be true. You know what? That makes kind of sense. Because this whole length of wire is going to have surface area. So I don't need this up here. And putting this down here is more... makes this look like what that was. That makes more sense. In fact, I wonder if this is needed at all. I wonder if this should be placed here. Because here's your capacitor increasing surface area. And then the neon should be here, and there should be no neon here. Just obliterate these and just go straight across. Because that's what the transmission network looked like originally. It just went straight across the magnetic area. And I had a neon bulb over this. Ah, that's right. Oh, so I got to redraw this. This was a nice attempt. I suppose it makes it look like Tesla's, like they're communicating. But they're actually communicating along this line. Yeah, we lose a line down here because we lose it to the Earth. So we don't really need an elevated aerial because this whole wire is the elevated aerial. I don't know. This actually, oops, gotta back up here. This actually makes more sense because now we got a load on both sides of the electric keeper. I wonder if I have to put another diode right in between here, because this is equivalent to earth ground. Which direction would I have it? Pointing down this way? Means I would need another one here. Oh, this is weird. See, I just assumed I'd leave it out because I assumed it would all go out the top. But I see, we may be collecting radiant energy from the top, if this is acting as an aerial, and the Earth, and it all has to go into the magnetic keeper in order to be translated into electricity. I'm just assuming that since I have it here, I'll need it here, but I could be wrong about that. I may just need another one here. Pointing downward. Get rid of this. Well, that is weird. So what that means is that this has no diode here. The diode is meant to protect the circuit, but why protect this area? You're trying to create instability. So you protect the area of stability, and you take away your protection, your diodes, protecting your area of instability. Because it's only through instability that we get the ability to harvest energy to power a load. So actually this looks more sane. And then we'll have to put another diode. Cross this out. And put another diode. Here. See, I read someone posted on an energetic forum on the Donald Smith message thread that it's a two-step process. You have to harvest the radiant energy, and then you have to pass it through a magnetic field to make it serviceable. So that's what we're doing here. We're harvesting it from the ambient environment, from the air, since this is our aerial up here, and from the earth. From the earth and from the aerial. Yeah, in this section up here, here, and here. But see, that's radiant energy, while electricity we're harvesting here and here. Or, oh no, we're servicing it. We could be harvesting radiant energy in the very place where we spend electricity, in this section here. But then we make the radiant energy serviceable outside this area, in here and here. So it's really two different phases of radiant energy, where we harvest it and where we make it serviceable. And that might be what these different poles represent. In a sense, this is our aerial here, this middle plate. So the wire is merely a transferring mechanism. I think he was saying the diodes in reference to serviceability, but well, no, it was the magnetic field was serviceability. So this is the epitome of an electrostatic field, and this is the epitome of a magnetic field. So we harvest it here, and we make it serviceable here, and then pass it magnetically over to here. Which means if we're harvesting it here, but we don't get to use it here. That's the difference. And we don't get to use this either. These are just used as reference points, as voltage-oriented reference points, because voltage is electricity. Voltage is not radiant energy. So these are just reference points on this pole, but they're points of harvesting for this pole, because these are connected through the ground. I wonder if this should be a plate, just as this is a plate up here, and this be merely a pole, a grounding pole. Which means we could have a pole come up here. You know, that could be. Yeah, it makes sense to put the neon bulb here because we got a plate above it. But if we have a pole coming, so that's something I didn't draw. I'm going to have to draw that. I'm going to have to draw a plate here, since I got it balanced with my plate up here, my middle plate, and the other two plates for that matter. And then a pole coming up here and a pole coming down here. So we're going to have different types of grounding geometries, grounding shapes, or aerial shapes for that matter, and they're going to alternate. So I just have to draw another diagram. I have to keep redrawing this. Well, I don't know. This is the best I can come up with. I thought I'd alternate the orientation of the grounding plates, horizontal versus vertical, but I can't get away from them being all vertical, just as this one is. So I've got a vertical plate there and here, and I got one here, and then this one in the line, and of course this is actually the load here. So that's the load. It skips over here and makes a direct connection here, a little resistor, and then the neon bulb, and then the middle capacitor plate, the center plate, and then the counter loop here, and then the vertical plate as an earth ground, the electric loop, the electric keeper loop, another vertical plate, grounding plate here, diode, coil winding, primary winding around the center post, and then going up to another diode pointing in, just like this one points into the magnetic area, and then a solid connection that goes over to this plate here and goes over to here to that plate over there, and this one comes up to another vertical plate, just like there's one down here. So I don't know. That's the way it looks at the moment. What do I know?